Welcome to the project demonstration of design and implementation of an ARM-based AI module for ectopic beat classification using custom and structural pruned lightweight convolutional neural network. So in this project we are using Raspberry Pi, which is based on the ARM processor, and the main application of this project is we made a structural pruned, means lightweight CNN which will run in the low RAM of our ARM processor. So based on these signals from the ECG will provide us the PQRST signals, and that will be according to this paper. We have like here, this is the proposed system and methodology. So from there we are going to estimate the time gap. So as we have mentioned in the paper, there's a 0.712 seconds. So this is a duration for one beat. And in that also there will be a PQRST signals in ECG signal. So we are going to estimate the time gap between these each pulse along with the amplitude of this RST signal and the next time gap between the PQRST signals. And based on these three variations we are going to estimate the diseases. For that we are using this classification for using this Raspberry Pi 0W we are using. And so this is the generalized PQRST signals. So as we discussed the RS, so this is the amplitude, the lower amplitude is S and higher amplitude is the R. This is the maximum amplitude while the system the heart pumping the blood, and PQRST is starting of the blood inhale and exhale from the heart. So these are the signals are going to getting from this AD8232 from these electrodes, and this is the PQRS signal is the analog voltage which will varies from 0 to maximum of 1000 ADC value. So between that the voltage varies, and that's the ADC value reflected by the Arduino Uno board which is used to convert the analog voltage which is getting from this AD8232 ECG module and to the serial conversion, means whatever the data is coming from this one. For example, if you are getting the 2.5 volts, so that will be representing as the 5 to 12. So that is the ADC parts. This is 0 to 1023, nothing but 0 to 5 volt. So based on these signals input from this AD8232 analog voltage and will be converted into the serial data, and that will be given as input to our Pi 0W through the serial communication. So once we receive these signals, it's keep on monitoring the signals. For every 10 milliseconds, the data continuously streaming to this our Raspberry Pi 0W through the serial ports. This serial communication. So whenever we capture the data, so it's keep on monitoring the amplitude variations and also the time gap. So amplitude and time gap. So these are the main input to our machine learning algorithm, that is the AI module. We are using the CNN, that's convolutional neural networks. There we are going to estimate the diseases. Totally we are estimate the 5 types of diseases. There's a tachycardia, arrhythmia and bradycardia, and also like low QRST signals. So this kind of the normal ECG. So these will be classified and displayed on the 16:2 LCD screen. And parallelly we are providing the heart rate and SpO2 from this MAX 30100 sensor and thermistor to get the temperature, and also fall detection with help of ADXL345. So these are the 3 sensors. We are getting the 4 parameters, and ECG is the 5th parameters. These are continuously plotted in a ThinkSpeak. So as a Raspberry Pi consists of ThinkSpeak, Wi-Fi inbuilt module, and so through that we are going to upload the data. After login to ThinkSpeak cloud platform, just click on data channel, and this is a fall detection status, and the next heart rate and SpO2 and the temperature and ECG values. So these are the captured values as we discussed. That's a 0 to 1023 value. Thus now we have captured maximum of here you can see that 657 is the maximum ECG signal value we are going to receive from this ECG module. And the temperature, wherever you click on the dots, we are going to get the value as well as date and time. So the main like inputs is ECG from this ECG electrodes to the AD8232, and from there to the our Uno board, and these 3 sensors providing the inputs of health related parameters like heartbeat, SpO2, temperature and fall detection. And these are interfaced to the Pi 0W, and the output module is the buzzer. Whenever the fall detected or high temperature detected, the system will provide us the audible alert through this buzzer board, and visual alerts continuously monitoring on the 16:2 LCD screen. And this one is a breadboard to distribute the 5 volts power supply throughout the input output modules. So before demonstration, the very first step is log into ThinkSpeak cloud platform and enable the hotspot in your mobile phone. So configure the hotspot name to project 7527 without any space, without any capital letter, and password should be 123456789, and AP band should be 2.4 gigahertz. So AP band should be 2.4 gigahertz. These three are main important setups. After enabling the hotspots and data, log into the ThinkSpeak. So if you want to get the fresh data, if you want to erase the old data, so you can take the backup of this one. So for that, data import export, and in that only do download the data. So it will be downloaded in Excel sheet, which will consist of date and time along with the number of samples till now collected, and field 1 to field 5. As we discussed, field 1 is the fault detection, and field 2 heart rate, SpO2, and these are the variables along with the temperature and ECG values. So this is the ECG values we are going to receive from the board to our Raspberry Pi, but they are received in 10 milliseconds of duration. After processing successfully done, the average value will be plotted to the ThinkSpeak. So this first one is a date and time, and the next column is till now how many samples till now we have collected. So we have collected around 88 samples. So these are fields. After we took the backup, now go to channel settings to clear the channel, and in that only clear the channel, don't delete the channel. On successfully clearing the channel, it will be cleared, and now go to private view. Now the old data got erased, you can see that. Okay, so now the next step is, first step is on the hotspot and data. Now mount the electrodes on your left and right hand. So left hand is this violet color, and right elbow yellow, and right wrist this red color. Okay, and now after mounting all these, now on the power supply to this adapter, and hold the reset switch of this board till a welcome message displayed on the LCD as well as the buzzer will come. That is indication of system got initialized. So we can place the finger on these sensors. This is set up till alright. Now you can release this reset switch of our board. So here you can see that heart rate, SpO2 and temperature fall, all 4 parameters are 0. When we release the switch, then it will continuously provide the input. Now you can see that it's calculating and monitoring on the LCD. Yeah, place the electrodes properly as we discussed. So this light indicated the ECG status. So if it is continuously high light on or low off status, that is nothing but electrodes are not connected properly. Right. So if anything abnormally connected, then the ECG will be detected the disease and classified by this Raspberry Pi and displayed on the 16:2 LCD screen. The parameters continuously uploading to the ThinkSpeak, as we can see that. So fall status and heart rate and SpO2 and temperature and ECG signal values here. So an abnormally detected, then abnormal heartbeat message will be alert on the LCD screen, and let us check this. Right. So here, once we place the finger over there, so when the abnormally detected, so like if you move the fingers or if you mount the electrodes improperly, then the system will detect that ECG, the so-called disease detected, or the arrhythmia. So based on the ECG signals. And coming to the normal case, wait for the patient should be normalized one, like no vibrations or any other things, then it will be stabilized to normal ECG. Wait till the parameters to be stabilized. So a normal ECG case. So for every time whenever we mount the electrodes, the light should blinks on this ECG module, so 88232. So that is the case. So we can see that slowly blinking. So when it is high brightness like this, so it's disconnected and properly mounted, then so you can see that slowly it will blinks the light off or high brightness. So you can see that we should mount these electrodes properly on the body so that we are going to get the exactly. So if there is any abnormality detected from there, then the disease will be identified and that will be displayed on this 16:2 LCD screen here. So in this case, bradycardia or tachycardia or arrhythmia, so these kind of diseases will be identified as we have explained previously here. Right, okay. So you can see that the LED blinking on this 88232 module. So it should blinks as shown here. So in case of no probes connected properly, then we are going to get the ECG signals ground to 0, and just we place it for we can place it over here also. Right, so just we are placing over here as we discussed properly. The LED should blinks with normal basic intensity instead of high intensity. Right, and coming to the temperature, that is the right. So whenever temperature crosses the threshold value of 100 degree Fahrenheit, as we are displaying the temperature in 100, so high temperature alert. It's normal again. So normal ECG. Okay, and coming to the fall alert. So let the temperature to cool down. Yeah, when it is below 100, then it is normal. Coming to the fall also, so fall alert. So these are the values stored here. Right. Thank you.